an irregular shape, meaning it's not a nice shape here at all.
No.
And they want the best estimate of the area and the of just the area. So we kind of want to make some boxes here, like see
Mhm.
how, I don't know, like that's kind of correct
Yeah.
there, and then this
And
is
then,
kind of correct.
mhm.
Then I don't know, maybe this is where it gets a little bit tougher. We got to kind of figure out, well, we're gonna take some and add some. So I guess I'll go do this and maybe go like
Can you
that.
can you give me a minute? I need to do something.
Sure.
Okay.
Okay, so now it's just a matter of counting these squares. I don't necessarily like this problem because the problem is that there's some half areas to consider, but let's see if we
Yeah.
can section off some nice regions. So this one for sure,
Hmm.
and this one for sure. So what
Yeah.
does that give us? That gives us 4
Me too.
times 2 plus 3 times 4. So we're at 8 plus 12,
20.
20, right? But
Hmm.
we've got some extra up here. I don't know, like maybe
That,
those three together make,
like that's 20. Like that would be like one and a half. Those like little halves, but
yeah. Yeah. Now what's interesting here is that our answer is not I'm just gonna sort of estimate our answer because it's not the bigger one as far as I can tell.
mm,
So anyway, we're kind of I mean, in some ways, estimation's a really good question, but the point is to be near the answer. Like the answer isn't 40,
yeah, like
it's near 20-ish. It's kind of like when you're estimating like how much you're going to spend on a project. You want to kind of get a rough idea.
yeah, like you don't like if you're exact, that's great. If you're just like
Yeah.
estimated to somewhere around there, that's great as well. It's just
So the other approach here is you just box in the ones that are for sure full,
yeah, that
and this is probably the more common approach. But what ends up happening is you have to then account for all these other ones. Like you have to say, okay, those two plus that's one more. And then you got kind of these three and that, maybe that's one more. And then you got these two, that makes one more. And you got that little bit. Like maybe these give you two. And then these last three give you one more. And then you're just counting squares,
yeah,
right? So imagine this one up here is down here. That gives us a 3x4 plus these three over here. So I don't know, it's around 15, we'll say.
yeah,
And whether that's right or wrong, I really don't know, but we're gonna just go with it because we don't have any better way of doing it. So
yeah.
um do you have Desmos open?
Of not
The
no,
graphing calculator.
no.
Okay. We definitely want to get it open here. And we're gonna look at these points. So I'm gonna graph the first one here.
Okay.
And you want to go to that graphing calculator we've used a few times. So you want to just plot each point -6 comma -2. I'll share my screen here in a moment, but let me just get it graphed. And then -10 comma 4. Label that an A. -6 comma 6. Label that a T. And then -2 comma 4. Label that a C. Okay. All right. So yeah, let me just snip this in. I think that'll be easier than you trying to do it on your own screen.
It's not a
Okay,
parallelogram.
that's right. but it could be a kite.
Yeah.
Now, do you remember how to find the area of a kite?
I don't recall, but maybe my notes.
So you have 1/2 diagonal 1.
Oh, that's right.
Times diagonal 2.
Diagonal 2.
Yeah. So diagonal 1 will go this way.
Mhm.
Okay, so it's the distance from -10 to -2.
Mhm.
So that's 8. And then we'll go this way, which is the distance from, actually, I didn't give you any units on the axis there. So let me check here what it actually is. This is -2 up to 6. So is that really also 8? Huh. It is. Sorry, just the scaling of this thing is weird. So the area of this is
64, and then you half of that is 32.
perfect. Yeah. So what's interesting, I guess, to me is that this worked out pretty nicely, which I didn't really expect. So the area is 32. Now the perimeter, remember how we talked about there's these triangles here?
Yeah.
So this one on the top here, this right here, I guess you can't see it. I'm sorry that but this is 2, and this right over here is 4.
Mhm.
Okay, so how do you find C?
You have to do a squared plus b squared equals c squared.
Perfect. So in this case, A is 2, B is 4. So we have 4 plus 16 equals C squared. So we have C equals the square root of 20.
Mhm.
Do you remember how to reduce that?
Yep. So it's where is that? Okay, so it'd be 2, and then there's the square root of 5. 2 times the square root of 5.
Perfect. And then this other one over here is the same because they're the same triangle. Now we have to do the same thing for this one down here. This is 6. This is 4. So we have to do 6 squared plus 4 squared equals C squared.
Mhm.
Okay, so that's 36 plus 16 equals C squared. C equals the square root of 52. Could you reduce that?
Yep. Two times the square root of 13.
Perfect. So this was what did we say? 2 square root 5.
Yeah.
This is 2 square root 13, 2 square root 13, 2 square root 5. So the perimeter is, you got to add them all up,
Oh,
right? For the perimeter. You don't have to, but that is the perimeter. Do you agree with that?
yes.
Okay, fantastic. So let's do the next one here. I'm going to just graph it here. And I'll snip it in. Unfortunately, that is the rest of our lesson is graphing these things and then determining what it is.
Okay.
So then just let me maybe we'll get lucky and we'll get a nice one. I don't know.
I remember there was one that was a parallelogram, but I might be wrong.
4, -2. Okay. Yeah, so let me snip this in, and this time I'll actually include some units to make it doable here. Yeah, so the next one, it's the same thing. We got to find the perimeter and the area. So if I draw connecting lines here, this is your parallelogram. What is the area of a parallelogram, or just more generally, what's the area of a rectangle?
Area of a rectangle is base times height.
Base times height. So kind of the nice thing here is that the base goes from 2 to 4. So the base is 2 units. The height, normally we do triangle stuff, but you can actually just count it here. It goes from -2 to +2. So what's the height?
That would be that's 4. Sorry.
4. So the area is 8. Okay, now the perimeter is a little tougher, right? Perimeter, we kind of know that these two are 2, okay?
Mhm.
And we know that the height here is actually 4. This
Yes.
is 2, okay? So we got to find this length right here, the C.
Ah,
Now we actually did that in the last problem,
yeah. So a squared plus b squared equals c squared.
right? But you actually already did the calculation.
Oh, that's right.
So what was C in the last problem?
It was 2 times the square root of 5.
Perfect. So the perimeter is 2 plus 2, that's the top and the bottom,
Mhm.
plus 2 square root of 5 plus 2 square root of 5.
Mhm.
So it's 4 plus 4 square root of 5. Is that okay?
Yes.
All right. So we got the next one here. I'll snip in the question. I'll also graph it. Um, the the real time consuming thing here is the graphing. Like without this technology, we would have to get graph paper out, and
Mhm.
we'd have to make sure we got straight lines. But this technology makes it really cool. It just gives you the graph that you need right away.
Yeah.
So 4, 3, and then 8 comma 3. There we go. Okay. So yeah, let me just snip in this image. Okay. So here I'm going to connect the lines, and hopefully you can tell me what shape this is.
It's not a parallelogram. That looks to be a rhombus.
Nope, it's not a rhombus. So
Oh.
a square pushed over is a rhombus.
Oh. That looks. What was it? It's got 4 sides, but they're not even.
There's only one set of parallel sides.
Yeah.
Okay, so go to the internet and do a search for one set of parallel sides.
A trapezoid.
Trapezoid. Okay. So what is the area of a trapezoid?
Area of trapezoid is 1/2 a times p. Or oh
Nope.
wait.
Base 1 plus base 2.
Sorry.
And,
Yeah. I was looking at a different one. Yeah.
okay, and the bases have to be parallel.
Yes.
So this is base 1, this is base 2.
Mhm.
Now, I know it's a little bit hard. If I were on your end, I'd be like, I'd be counting, but do you see how it's right minus left?
Mhm.
So what is base 1?
So that's 4.
It's 4. Base 2, this is actually at 12, and this is at 0. So what is base 2?
Is that 12?
Okay. And then the height, you can obviously count here. It's 3 up and 4 down.
7.
Okay, so that's 7. You can also do top minus bottom. So let me show you
Oh,
that. The top is at 3. 3
yes.
minus a minus 4. What does that become?
That becomes 3 plus 4, which is 7.
Perfect. Okay, so this is 16. Half of 16 is 8. 8 times 7 is
8 times 7 is 56.
perfect. Okay, now this triangle right here is a right triangle.
Yes.
Okay, what is the height?
The height is 8.
And the base here is 4.
4.
So I want you to find C. A squared plus B squared equals C squared.
Okay. It's gonna be 4 times the square root of 5.
Okay, so let me just double check here because I was surprised by that number I just heard. Oh, you know what? This is not 8. This is 7.
So then,
4
does that,
squared plus 7 squared equals c squared.
oh,
I wrote the wrong number down. Probably for what you said it was correct.
uh, hmm. I get 5 and 13. So
So what you're saying is that when you add these, it's the square root of 65.
65.
So
Yes.
65 reduces to 5 and
5 and
13.
13.
They're both
Yes.
primes, so this is what it remains. Do you agree with that?
Yes.
Okay, good. All right. So we're up to the last one. I know this lesson took a while. Hopefully the next one's shorter, but my guess is it won't be. But let's take a look here. So let's take a look here. 2 comma -4. -3, -2. And -5 comma 3. All right, so this one may be a rhombus. I'm going to take a look here. I know you can't see it yet. Let me get the snip in.
All right.
All right, so the connecting dots here, we're connecting that one, that one, that one, and that one, right?
Yeah, that's a rhombus.
Kind of looks like a rhombus. We can probably say that it is for sure a rhombus. So the area of a rhombus is diagonal 1 times diagonal 2.
2.
Fortunately, these aren't all that easy to figure out.
Could you go like from bottom up? So like you go right and then up, or does
Well,
that not work?
these are right triangles. So we could do some things with the lengths, but none of the lengths are nice either. So it gets because the way the answer space is, we can actually just focus on the perimeter, because once we get one of them, they're all the same. And there's other ways to do the perimeter. So let me show you that here. I'm just gonna grab a slightly different color here. This is what's hard about geometry. Sometimes you have to draw lines that don't exist. So this is 2, and then this is 5, and then you can find C. You see that?
Yeah.
So 4 plus 25 equals C squared. C equals the square root of 29. And there's 4 of them, obviously. So
Yeah.
the perimeter is 4 of those. Okay, I'm gonna take a look at the next lesson here, or maybe jump to one that's a little bit more straightforward, meaning we can do it quickly. Let's take a look here though. So just I'm scrolling here on my side, and then you can take a look here. So we just did 9.25W. Okay, let's look at 9.24. No, we already did that. That's another one. Okay, let's do a couple of these and we'll see how far it goes.
Okay.
And I don't enjoy these. I think that I think they ought to provide the grid for you so that you can give this a try here. But I think this is the next one. Okay. Really odd. Okay. All right, so it says I guess we need to look at these two shapes. So do you see this triangle right here?
Yeah.
Okay, I don't think they actually mean for it to be separate. I think they just didn't connect out the like I think you're supposed to find the area of this.
Yeah, that's what I'm thinking.
Okay. And then similarly over here that the area of whatever this is. So to answer this question here, because the answer space, let me pull up the answer space. Um, well, actually, we just need to find the area, because if you look at the answer space here, see they're all the numbers are different.
Yeah,
So we just need to find the area of one or the other. So which one do you like better, the left or the right?
I'd probably go with the left. Seems
I
a
knew
little.
I knew you would say that, but we're actually gonna do the one on the right because it actually is only two calculations. Okay, and I'll show you that
Oh,
here. So let me switch the colors up here. Um, okay, so the one in blue here, this is the height I'm drawing, and
mm-hmm.
this is the base. So it's 1/2. The base here is 4, and the height is 3. Do you see that?
Yeah,
Okay, and then the red is also a triangle. What's the formula of a triangle?
it's 1/2 base times height
Okay, so the base this time is 2, 4, 6, and the height is
is 1, 2, and 3. So,
okay. So what does these add up to?
so oh,
What do they
it,
add up to?
oh, that adds to 6 to letter C. It's
What does it add up to?
oh,
What is 6 plus 9?
6 plus 9 is 15.
All right, let's look at another one here, kind of like this. So this time I want you to do this on your own. You can choose either one. Okay, and
Mhm.
it's really similar because it's either the left or the right. I think you'll find this time that the left is the right one to do.
Yeah, I'd choose left.
This is odd. Like, the area of this one is 9, right?
Yeah.
But like, I almost think that that's not the right answer here.
What
Because
are the answers? Well, what do they
well,
tell
well, look,
us?
well, look. If we move this here,
Yeah, I know. Then that
then
gives,
it is 9, right?
yeah, that's also 9.
I
So
don't. Well, I guess I'm just speaking out loud. I don't really understand what they're trying to emphasize here. Um, okay, so new problem here. Do you have your Desmos open?
yes.
Okay. So what I want you to do is graph these 4 ordered pairs. Actually, this isn't going to be all that easy. I'll graph it. Because what you need to be able to do is you need to be able to connect the dots.
Mhm.
Um, okay, and then and then find the area of it. And you're how are we going to do this? Okay, so let me snip this in. How much more time do you have today, Christopher?
Um, 10, 20.
Okay, let's we can go a little longer then. So wait a second. This is odd. So it's not even a parallelogram. Um,
This looks more of like a rhombus, but then
so
I,
let me show you what I see, and I don't know if this is what they intended, but I see this shape right here.
Mhm.
I see another triangle here, another triangle there. I see those 4 triangles.
Yeah, that's what I see.
1, 2, 3, and 4. So we got to just find the area of each of them. So the area of one is 1/2 base times height. So the base is 1, 2, 3, 4, 5, and the height is
2.
okay. The second one is 1/2. Its base is 3, and its height is 2.
Hmm.
The third one, its base is 4, and its height is 2. And number 4, okay, its base is 2 and height is 2. So you got to find these 4 numbers and add them up.
14
14.
is my final answer.
Okay, good. All right, so the next one is really similar. Let me snip it in and then I'll graph it. Get this in here. This one's got a lot of twos in it, so maybe it's a nicer looking shape. I really don't know until we get that. So we got 3, 2, and 7, -2, and 2, -4, and 1, -2. Ooh, so again, it's just not a real nice.
Oh, can we do the same method
Yes.
that we use?
Yeah,
Okay.
it's just it's like just it doesn't really look nice at all here, but let's give it a try here. So let me switch back to this. So like one of the things I see here is, okay, there's a triangle that we can draw, and then here's another triangle that we can draw, and then this last one we actually, because they're on the same one there, so there's actually only 3 this time. So I want you to try and find the area of each one.
Okay. My final answer is 20.
All right, let's take a look here. So this is, okay, so let's maybe I didn't graph these right. Let me just check that I graphed them correctly. 3, 2, 7, -2, 2, -4, 1, -2. Okay, yeah, so let's look at them one at a time. So it's 1/2. The base for 1 is 2 and the height is 4. Okay, so what is that an area of?
The 4.
Okay, the second one is 1/2, base of 4, height of 4, which is 8. And then the third one here is 1/2. The base is 2, 3, 4, 5, 6, and the height of 2. What does that equal?
That's 6.
Okay, so try adding these up one more time, please.
18.
Very good. All right. So yeah, we got 2 more here. We're going to do both of these, and then we'll be done with our 2 lessons for today. So let me snip this in. We'll probably end up using the same approach again, but let me graph it and snip that in for you. So I'll take a look here. Yeah, so again, this is kind of an odd shape, but this one, the way, because we've got these 2 right here, we could have actually done this in the last one, is we can actually just build 2 triangles.
Looks more like a kite, but
it maybe has the appearance of that, but they're kind of offset here, and the diagonals don't meet at 90 degrees. So let's just have you find the area of both of those triangles.
okay.
Again, they're just 1/2 base times height. There's nothing unusual about them.
I get 22.5.
Yeah, that looks pretty good. Okay, believe it or not, we're on our last question. And it's it's the same. It's because you're doing so well, you get to do a lot of them like this.
Yay.
So I don't know if you're thinking this way or not, but when I do a lot of the same things over and over again, I think, well, there must be a faster way, right? There must be a way to kind of automate this, or there might be a program or a software that can be used to answer to do the same calculations you're doing. And there truly is. Like you're doing these by hand, and that's great, but you could, there are ways to automate this process. And unfortunately with this one though, you don't get the nice triangles. You got to do more than one here. So we've got this one. It is nice though that we can come up with all of these different triangles here. Let me see. Nope, I guess this one doesn't really lend itself to that.
Maybe if you were to get that line to go all the way down. Well,
Yeah.
actually, never mind. That doesn't work.
Well, let me just connect them. I'm trying to freehand it, but it looks like it might be that this one, we do have three. So we got 1, 2, and 3. So give that a shot there. See if you can come up with the right answer for that one.
I get 20.5.
Okay. Yeah, and I may have made a small like adjustment here, but that looks pretty good. Okay. So we're going to see how we did on that. I think we did great. All right. So that does take us to the end of our lesson for today. I'm going to go ahead and pause the screen recording, but please stand by.
Okay.